Hello guys, welcome to this video. In this video we will be talking about binary search, and it will be a continuation of our previous video where we covered divide and conquer. And if you haven't checked that out, please check it out. So let's begin with today's topic of binary search. So here you can see that given first I'll just uh, tell you the crux of the binary search. Uh, so as you know that binary search is a searching algorithm where we have to search and target element in an sorted array. So you have to keep in mind that it only applies in the sorted arrays, and in it is a kind of divide and conquer algorithm, but we should not call it divide and conquer because is more of a reduce and conquer algorithm. Okay, so in this let's just tell you with some example. Let me explain it. So given you have an array and you have to find a target element, let's say 23. So we will first find the middle element. Let's say now in this array it's 16. So if the target element that is like we have to compare the target element with the middle element, and if it is less than middle element then we will search for the of the left part from the middle element, and if it is greater than the middle element then we have to actually search in the right part from the middle element. Okay, so in here, as 23 lies in the right sub array of this big array, so we will search in this part and we have to again uh, actually find the middle element and repeat the steps. Okay, so here we find that 56 is the middle element, and as 23 is less than 56, so we have to find in this uh, left sub part or sub array. So now when we find middle element it's 23, so it will return the index of the target element found in the array. Okay, and if it is not found, if the target element is not present in the array, then uh, we will return -1. Okay, so this algorithm actually works in order of log n times because there are there are log n levels, because we have to divide this first into two halves, then we will so n by, let's say it is of n size, so in this level it will become n by 2 size, then in this level it will become n by 4 sized, and then in this one it will become n by 8 sized, so like that. Okay, so the total levels will be here log n, so the time complexity is actually log n, and it is way better than the linear search where it actually takes an order of n time complexity for big O of n for actually searching in an array. Okay, so just let's see on the code. So first we will actually see the recursive relation, like recursive code. We, let's say it's in C++. So see, we are first taking an element and we have to find the target 10, and we are taking the size of n, and we will just pass the array, the starting index, the end index, and the target element. Okay, so here you can see that when we get these parameters in the function, so we will check first of all that if r is greater than or equals to l, so right, that is the right index is greater than or equals to left index or not, and if it is, then we will go inside and find the middle element, and um, and by the way, this r minus l, like we can also do l plus r by 2, but sometimes this r minus l is required because there may be integers, like let's say the array is larger than the integer max value. Okay, so this is for that case, and actually if you will solve this then you will get r plus l by 2 only. So yeah, And now we will compare if the middle element is equals to target or not. So we will return middle element, and if it is, if the middle element is greater than a target, that is target lies in the left side, so we will search in the left side up to the middle element. So we will return this in recursive call. We will be actually recursively calling this binary search to search in the array from the left index to the middle minus 1 index with the target x, and if it is like less than x, then we will return this binary search in like we will search for the target element in the array starting from middle plus 1 index to the last right index. Okay, and if we do not found any target element, then we will just return minus 1. So this is a kind of recursive, like not a kind of, but a recursive implementation. So let's just now take look at the iterative approach. In this approach, we do not actually call the binary search again and again. Just we have a while loop, and it runs up to when the left index is less than or equals to the right index, and we check the same things. Just the case is that we do not, in here we do not call the function recursively, and just tell that the left index is the middle plus 1 and the right index is middle minus 1 if the target is less than the middle. Okay, and we will similarly return minus 1 if it is not, the target is not in the array. So yeah, uh, time complexity of binary search can be written as this tn equals to tn by 2 plus c, and yeah, the above recurrence can be solved either using the recurrence tree method or the master method as told. So you we will matlab means checking this in the actually master method. We will discuss about this as well. Like you can also check here. See, in this master method, you can see that there is a relation that we have to actually memorize. So um, one second. Yeah, here it is. So here we have to actually memorize that, and if we have a recurrence relation in this form, then there are certain cases that we have to follow. For now, just say see that this is the binary search one, and according to this we will find comparing to this relation, the green one, we will find the values of a, b, and k and p, and accordingly we will see that the case 2a is there, and we have to actually replace theta with this, and we will get order of log n time complexity. Okay, um, and the auxiliary space is order of 1 in iterative implementation, and for recursive it is order of log n, because as you know we are not actually decreasing the array, and we are actually search, like not like there will be the stack calls will be up to log n levels. That's the reason for the recursive call stack space. Okay, now this algorithm, as I told you, that is more of a decrease and concur, and so this was it, and yeah, you can check it out as well. All the links will be in the description. But yeah, that was all for the binary search as of now. So meet you in the next video. Until then, keep watching and keep learning.